Hey, welcome back. Okay, so yesterday we left off with our passage that I was going to read to you, so I'm going to read that to you now. To get there, if you want to read along with me, then what you can do is pause the video real quick and then pull it up, and then you can play the video, and in the background while I read it, you can follow along. So let me go ahead and share my screen, or you can just read it with me, just either one, it doesn't matter. You can still see it on my screen. But if you want it up on your screen, all you have to do is just come here to the science linked activities. Let me go ahead and share this so I don't forget. Right here. And go to Mystery 1, go to Volcano, pop up where you live, hit play, and then go to the end. All right, so if you haven't already, check out these two awesome videos. I've already watched them. I'm not sure if they're copyright. That's one reason why I didn't do it on YouTube, is because if it's copyright, then it won't show up, and then you can't see the rest of the video. And also because we kind of don't have time to show you right now. I need to just go ahead and get to the reading so we don't lose pace. So yeah, check these out. If you haven't already, pause and go up here. They're really cool. So I'm going to read this reading, The Pacific Ring of Fire. And this is how you get to it. I'm going to read it over on my end, over here. All right, so the Pacific Ring of Fire, home to 452 volcanoes, by National Geographic Society, adapted by News ALA staff on 4/17/19. This is a level 830L. That's kind of high-ish. So this image right here, the steam is rising as lava from hold on, I practiced saying this. Kilauea flows into the Pacific Ocean in Hawaii, September 2016. So lava levels of one of the world's most active volcanoes rose quickly and showed no signs of slowing down. Kilauea volcano in Hawaii had seen a rise in its magma chamber in recent months, with this lava lake visible to all visitors to the Hawaii Volcanoes National Park. Photo by Mark Sesglat, Barkoff, Media via Getty Images. This is such a cool photo. And if you don't know already, I'll remind you that whatever rocks comes from magma, when it cools down, they're always going to be igneous rocks. So if it comes from the lava and it cools, igneous. There's three types of rocks: igneous, metamorphic, and sedimentary. You might remember when we did that in class, but igneous is from the magma cooling. Sedimentary is when like little bit sediments, like sand and things like that, get pushed together, a lot of pressure, and then they make a rock. And then there's also metamorphic, which is a heat and pressure pushes together. Okay, so the Ring of Fire is a string of volcanoes and earthquake sites all on the edges of the Pacific Ocean. About 9 out of 10 earthquakes happen on the Ring of Fire. 3/4 of all active volcanoes on Earth are along the ring. The Ring of Fire is shaped like a 25,000-mile horseshoe. It contains 452 volcanoes. The ring stretches from the southern tip of South America, so that would be right here, because south is the bottom. Never eat soggy waffles, so south is the bottom. So this is South America, and then the south of South America is right here at the tip. Over to eastern Russia, all the way over here. Down through Japan and into New Zealand. A group of volcanoes in Antarctica close the ring. So it comes all the way up through here to Russia's here. Then you go around and then comes down here in Antarctica, which is a crazy place to think a volcano would be in Antarctica. So, plate boundaries. The top layer of Earth is called the crust. I hope you remember when we were in class and we had a visual of it when we did the different types of rocks. If you remember, the crust is There is like a few miles, but we've never gone past the crust because it's so much. But just a very thin layer is the crust, and the crust is split into huge slabs called tectonic plates, which are as large as continents. The plates are always moving, but they move very slowly. Sometimes they crash together, move apart, or slide next to each other. The boundaries or edges of these plates form the ring of fire. So if you don't remember, whenever these plates come up together and there's no room, what happens? If you have two plates like this and they come like this, what's gonna happen? Well, one thing is gonna happen is they're gonna bounce off each other, or they're gonna hit and crash, right? So if you take anything, if you had two cars and they go like this, are they just gonna touch and that's be it? No, there's something's gonna happen, right? Especially if they're going fast enough. So maybe these aren't going as fast, but they're really big. I mean, they're the Earth, they're humongous. So even if they're going really slowly, when you have, I mean, who knows how many pounds, but this humongous side of this Earth and this side of this Earth, and they both touch, it causes an earthquake. So if they're still pushing and there's nowhere for it to go, well, if this one's trying to go this way and this one's trying to go this way, then this could happen. They could go like that, and then a little mountain can form like this, or they could push into each other like this, and they could go. There's no place they can go. It can't go down because there's more dirt there. The only place they can go is up like this, and then you will have a big mountain, and that's how some mountains are formed, like the Himalayan mountains. You can see seashells on them and other ocean fossils because there was once a sea, and then the plates slowly over time just kept pushing up. Pretty awesome stuff. Okay, so let's keep going. So the boundaries or edges of these plates form the ring of fire. Convergent boundaries. There are three types of plate boundaries. A convergent boundary is formed by tectonic plates crashing into each other. At these boundaries, the heavier plate can slip under the light plate. The rock underneath gets so hot that it melts. The liquid rock is called magma. So the liquid rock rises through gaps in the crust over millions of years. When it reaches Earth's surface, the magma creates volcanoes. So you can't see it very well, but I'll zoom in after this paragraph. Divergent boundaries. A divergent boundary is formed when tectonic plates pull apart from each other. So instead of pushing together, they come apart like this. The old crust pulls itself in opposite directions. Magma comes out from below to fill in the space. Then cold seawater cools the magma, creating new crust. The upward movement and eventually cooling of this magma has created high ridges on the ocean floor. So I remember I asked the question in our other video, where are all the places that a volcano or magma can form? And it can even happen underwater. I know it sounds crazy, like deep in the ocean, but it is possible. So where was I at? Right here. Let me zoom in. Whoa. All right. So all these fancy schmancy words, these are big words. I'm not gonna go into that right now, but you can see this is where it goes divergent at, is where it comes apart. So then when it comes apart, you're gonna have this hole here. So either water is gonna go down or magma is gonna come up, or both. And then, it'll fill in. And if there's a lot of pressure, the magma might push through. And these are islands right here. This is like when two plates, when they push up against each other, sometimes they slide beside each other like that. So this is what's happening here. Okay. Let's zoom back out and keep going. So a transform boundary is formed when tectonic plates slide past each other. Parts of these plates break or slip as they rub against each other. The plates push forward and cause earthquakes. The gaps between the plates are called faults. Most of Earth's faults can be found along transform boundaries in the Ring of Fire. The San Andreas Fault is one of the biggest faults on the Ring of Fire. It lies on the transform boundary between North American Plate and the Pacific Plate, measuring about 800 miles long and 10 miles deep. The fault cuts through California. Hotspots. So the Ring of Fire is also home to hotspots. These are areas deep inside the Earth. As heat rises from a hotspot, it melts the rock above it. The melted rock or magma often pushes through the cracks in the crust to form volcanoes. Active volcanoes in the Ring of Fire. Most of the active volcanoes on the Ring of Fire are found on its western edge. So that would be to your left. West is to your left. Not always to your left, but just your west is left. Krakatoa is an island volcano in Indonesia. The country of Indonesia is a group of islands between South Asia and Australia. Under Krakatoa, the denser Australian plate is slipping beneath the Eurasian plate. So I know this is a whole lot to understand, but just keep with me and it'll make sense. Mount Fuji is Japan's tallest and most famous mountain. It is also a volcano. Mount Fuji sits at a triple junction where 3 tectonic plates come together. So instead of 2 coming together like this, there's one here, and then another one, and then they're all coming together. So yeah. The Ring of Fire's eastern half has active volcanoes. Mount St. Helens is in the U.S. state of Washington. It lies on a weak section of crust. That makes it more likely to erupt. Why does that make it more likely to erupt? Well, if you think about, how do I think about it? Just imagine if you had if you just had a very thin layer of dirt and something's trying to come up, right? So if something's trying to come up, do you think it's easier to come up when there's a little amount of dirt at the top like this, or if there's a lot amount of dirt and they're just stacked on each other like this? Of course, it's going to be easier when there's a lot less dirt because there's less to push up. So let me see. So Popocatépetl is one of the most dangerous volcanoes in the Ring of Fire. The mountain is one of Mexico's busiest volcanoes. It has erupted 15 times since 1519. Fast fact. So jolting Japan. Japan lies along the western edge of the Ring of Fire. Out of all the eruptions in the world, 1 out of 10 happen in Japan. That's a lot. This makes it one of the busiest places on Earth for volcanoes. Cooling ring. The Pacific Plate causes much of the action in the Ring of Fire. Scientists have found that the youngest parts of the plate, which are about 2 million years old, are cooling off. These parts are getting smaller faster than the old parts of the plate, which are 100 million years old. The younger parts of the plates are the busiest parts of the Ring of Fire. Awesome. So I hope you guys enjoy that. If you have any questions, you can email me. And what we're going to do is we're going to go into tomorrow we're going to go into the next thing. We're going to do why do some volcanoes explode? And we're going to pick off here. Okay? Well, it was good reading with you guys. I hope I can see you again. I'll see you. Bye.